Greetings and welcome. I'm thrilled to be here, Leonard Lobel, speaking here at Data Platform Virtual Summit 2022. And it's a pleasure to be here with you today to talk about securing Azure Cosmos DB. Let me just start by jumping right into our agenda. This is an entry-level session in terms of the topic that we're covering, which is security, but I am assuming some basic knowledge about Cosmos DB, at least that you know something about it, that there's a Cosmos DB account and the master key and stuff like that, because we are going to be focusing on security in three pillars of security, beginning with network security, which we can use an IP firewall or a virtual network-based firewall or a virtual network-based firewall that uses private endpoints, not just service endpoints. And this is really your first barrier, right? Your outer gate. You know, if you can't establish a physical network connection, then you can't even get through to the point where you might want to get authenticated at that point. We've had authentication with master keys for a very long time. We are going to talk about authentication with the resource tokens, which addresses some limitations of master keys. We've also had resource tokens for a very long time. Much newer is Azure Active Directory integration, and we'll have a look at that. And then the third pillar of security here, if you will, is of course encryption, where we get server-side encryption kind of baked into the service, but we'll also have a look at client-side encryption, where another word for it is always encrypted, where you have certain sensitive data that even if you get through the network security and you get through the authentication, it still will not, the data will still be encrypted unless you have the necessary client-side credentials or client-side key in order to decrypt the data. So let's start with network level security. There's a couple of ways that this can be done. Cosmos DB is of course a public service, and so it has a public endpoint, and it is therefore accessible from anywhere on the public internet. And that's really great and convenient when you're getting started, right? If you're just getting started with Cosmos DB and you're doing your development, you can access it from anywhere and everywhere on the internet. And that's wonderful. But of course, obviously for production scenarios and production workloads, that's way more exposure than you would ever want to have. And you'd want to lock things down for those sensitive production workloads. And that's where the IP firewall comes in. And this works very similar to the way you've seen firewalls work in many other systems. You have an approved list of IP addresses or IP address ranges, and only clients that come from those IP addresses are allowed to access your account, right? And at that point, your account is going to be accessed by its public IP address. So this Cosmos DB, it has a public endpoint, it has a public IP address, and here are two clients that would normally be able to access that public endpoint. But if I put up the firewall and I approve the IP address of that first client, then requests from that client will be allowed to flow through the firewall to the public endpoint and onto Cosmos DB. But if I don't approve the IP address of that second client, it will of course get blocked by the firewall. Very simple, very basic, very powerful though, and very effective. But there's a bit of a maintenance burden involved here, where you need to maintain this approved list of IP addresses. And so you'll see in a moment that can be simplified with the virtual networks. But for now, let me give you a little walkthrough of how you would configure the IP firewall. Right here in the Azure portal, you hit networking, and you'll see that by default, public access is set to all networks. Which, like I said, that's the default. But of course, as soon as you choose selected networks, that opens up the page. And there's two parts of this page, the top half and the bottom half. Right now, we're looking at the bottom half. And this is where you plug in those IP addresses, where the portal is able to pick up what your current IP address is and gives you a link to conveniently add it. And here I've gone ahead and added it. And that's really all there is to it in terms of maintaining this firewall. Now, we should point out these checkboxes here that we have down at the bottom, both of which are unchecked by default. But the first one you would want to keep unchecked. It would be highly undesirable to check that first checkbox because that will bypass the firewall for all connections within Azure data centers, and those could be virtual machines from other customers. Right. So the only time you would ever check that first checkbox is if for some reason you can't access the public IP address of a service that you know that you have that needs to connect to Cosmos DB. The second checkbox is much safer to check, and you probably will want to check it. It used to be checked by default. They recently changed that default. So I go ahead and check it because you don't want to block those middleware portal IP address connections, such as the Data Explorer. Like if you don't check that second checkbox, you won't even be able to use the Data Explorer in the Azure portal. And if you want to be able to do that, you will check that second checkbox. Okay. So you hit save, and because this is a walkthrough, it finishes very quickly. But in reality, they say it can take up to 15 minutes. I've seen it in practice take about 5 minutes, but even that's a chunk of time to wait. But that's due to the distributed nature of the service. It has to propagate. So it takes about 5 minutes, and once that's done, you're all set. So like I said, it could be a bit burdensome to maintain those IP addresses. And so a very similar approach that you can take that's a lot more convenient is a VNet through a service endpoint, a virtual network through a service endpoint. It's the same concept where you have a firewall that only approved virtual networks can have traffic that flow through the firewall. But then any clients inside, any resources inside of that virtual network, without you having to manage their individual IP addresses, are able to connect to Cosmos DB, but no other virtual networks, no other connections will be permitted. Only connections that will be permitted will be connections coming from resources inside the specified approved virtual networks. Now, we still got a public IP address in place here that's exposing our Cosmos DB account. And this time we have several clients, but rather than be concerned with their individual IP addresses, we will contain all of them inside of a single virtual network and expose the public endpoint to that virtual network in the firewall by approving that VNet, which opens up a service endpoint, which connects to the public endpoint, which connects to Cosmos DB. Right? And it's conceptually very similar. If you were inside of that VNet, however, right, if you're inside of that VNet and you do an NS lookup, what you'll see is that the IP address of that Cosmos DB account is still a public IP address. So Cosmos DB is still publicly accessible over the internet, and this virtual network, this VNet itself, the resources inside of this VNet are themselves publicly accessible and have public internet access. They can access the internet and vice versa, right? So the way this works, well, that's the top half of the same page that we were just looking at a moment ago. For selected networks, instead of maintaining a list of IP addresses, we just maintain a list of approved VNets. I can create a new one on the fly here and add it, or I can add an existing one. I'm going to go ahead and add an existing one, and you get the whole list here on the right, and you can check off more than one, but I'm just going to check off this one particular VNet and add it to the approved list of virtual networks. There it is. You can see the 10.0 address is a private IP address for that VNet, and hit save. And again, you would wait a good number of minutes for the firewall configuration to be updated, and at that point, you've got actually a combination here. So that IP address plus all resources inside of this VNet can access, plus the Azure portal, because of that checkbox on the bottom, can all access the Cosmos DB account, but no other clients can. Right? Those are the main components of this page here. So what's the potential problem with this? Well, the potential problem with this, as I pointed out, is that the VNet itself is exposed to the public internet. So even though it's true that only resources inside the VNet can connect to the public endpoint, in certain scenarios, you might be concerned about rogue users who do have access to that VNet, who can therefore connect to Cosmos DB, who might then want to exfiltrate or export, basically suck out private information and drop it anywhere on the internet, which is something you obviously wouldn't want. And if you want to protect against that, then we have our third option here, which is still based on virtual networks, right? So only resources inside the VNet can access Cosmos DB, but it uses something called a private endpoint. And the marketing term for this is private link. And this is not something that's specific to Cosmos DB. This is kind of a general Azure thing. It's a general Azure concept. And like VNets through a service endpoint, you can only connect through approved virtual networks, but now practically the Cosmos DB account itself does not have a public IP address, and the VNet does not have public internet access. And the way this works is Cosmos DB, well, technically it actually still does have a public IP address, but when you set up private link, that public IP address is completely locked down. Like, it's just inaccessible entirely. And the only way to get through Cosmos DB is with a private endpoint. So I have a VNet like I had before, and I have my resources and clients that need access to Cosmos DB contained inside that VNet like I had before. But now I also create this private link, this private endpoint, this Azure concept of a private endpoint as a resource inside of my VNet. And that is able to access Cosmos DB through a private IP address. Like there's really no publicly accessible IP address anymore to Cosmos DB with this configuration. And to prove that, you can go in, if you're inside of that VNet and you run an NS lookup like we did before, you'll find this time that it's a 10.0 address. It's a private IP address. There's actually no access to the internet from this VNet, no way to connect to Cosmos DB and then export out of the VNet to the public internet. Simply not possible. And this is what I'm going to demonstrate this for you in a moment. But the way to just walk through the process in the portal to configure this feature is you click on private access. And when you click on private access, this is where you can set up your private endpoints, right? Your private link. You click on new private endpoint. Like I said, this is kind of a resource unto itself. So like any resource, you have to first, choose a resource group, for it to live in. You have to name the resource. I'll call it my private endpoint, Power Original. So I've got my private endpoint. And what I want to do is, what in Azure do I want to associate this endpoint with? That would be my Azure Cosmos DB database account. And within that type of resource, I name my specific account, and that sub resource there is just the API. It's a SQL API in this case, right? And go ahead and move on, and then choose the actual virtual network, right? Choose the actual virtual network that the actual VNet that this endpoint is going to be associated with. DNS is something that's what kind of like does that magic of just like making the NS lookup suddenly resolve to a private IP address, so it can connect to Cosmos DB through a private IP address since the public IP address is no longer accessible. That happens automatically if you integrate with the private DNS zone, but you can check no here and manage the DNS yourself. It's a little esoteric. You just keep that checked off as yes, and it will work just fine. No tags. We'll hit create, and we've created our private endpoint. Again, this might take a little bit of time. These screenshots are giving you the walkthrough experience. Then you go to the resource and you see, indeed, there is your new endpoint called my private endpoint. And this is the VNet, right, that is associated with right here, Cosmos private link VNet / subnet, and that's the default subnet. Okay, so if I go back to that networking tab that we came from, coming back in Cosmos DB where I created this endpoint, if I go back to public access, well, first of all, there you can see my new private endpoint that I just created, right? If I go back to public access, what you'll see is that the all networks option has now been disabled. Once you have one or more private links, you can never choose all networks again. if you don't have any private endpoints, you can always choose all networks to turn off the firewall. But once you have private links, until you kill all those private links, until you delete all those private endpoints, you will never be able to switch back to all networks. And the tooltip there explains that, right? You can't choose all networks because this account has approved one or more approved private endpoints. All right, how about time for a real live demo on private link? So I'm going to flip on over to the my homepage, where you can see I've got a virtual machine that's running, and I've got a Cosmos DB account. And if I go to my Cosmos DB account and I go to the networking tab, like we just saw, and let me pump up the font size a bit for you guys. Okay, and I go to the networking tab, like you just saw on the slides, you'll see all networks is disabled because I do in fact have a private endpoint. It's called Cosmos Private Endpoint. If I click on it, I can see that it is associated with this virtual network and subnet, Cosmos Private Link VNet. Well, you'll see that I also have a virtual machine, and that virtual machine is running inside of that VNet. So that means that this virtual machine, and only this virtual machine, should have access to the Cosmos DB account. And to prove this out, I've got this code here running both locally on my machine, which is of course not inside that VNet, as well as inside that VM that is inside the VNet. And let's pop inside the VM first. Here I've got remote desktop up. I'm inside that VM. The code is not doing anything interesting. It is only, it's really just testing access, and access is all that we're trying to demonstrate here. Like you either can access this account or you can't. So I'm just doing some basic things like creating a database, creating a container, creating an item, reading it back, and then just deleting it all, right? Will this work? Well, let me go ahead and hit F5, run it. Hit my breakpoint, and let's see, can I create the database? Yes, that seemed to work. And I create the container. That seemed to work as well. Let me just hit F5 and let it just go all the way through, because clearly everything's working and all our operations completed successfully. And that's expected because we're inside the VNet. Now, outside of the VNet, get rid of this remote desktop window. Now I'm on my local machine, on my laptop here, my Surface. And this is the exact same code. All right, running inside of Visual Studio. Let me give it a run. Let's first try to create the database, and that just flunks right there. That just fails right there. And you'll notice that we're caching specifically a Cosmos exception, so not just any old exception, and not just any Cosmos exception either, but only when the status code is forbidden. That's a 403 status, which is what gets thrown when there's a firewall or a private endpoint blocking access, blocking network access. And here in this case, I'm getting access is blocked by Cosmos DB firewall or private endpoint. Yada, 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 and even shows the IP address, right? Blocked by your Cosmos DB account firewall settings. That's Cosmos message. All right, so that is the IP firewall. I'm sorry, that is private link actually, and that's the end of network access. I'll pause at this point. Well, first of all, to make sure that you guys can all still hear and see me out there, as well as to see if there's any questions. But I don't see any. I don't see any queued up yet. Am I still getting a good connection on audio and video?
Yeah, all good, Lenny.
Fantastic. Thank you kindly. All right. So let's move on to our next topic, which is authentication. Okay. So you've established a physical network connection because you have gotten through the firewall, or you have a private link set up, and now you have to authenticate. How do we authenticate? So from the beginning of time, we've always been able to authenticate using the master key. And the master key, it works, right? But there are several problems with it. It grants full access to the entire account. There is a master key that grants read-only access, but it's still to the entire account. There's no granularity. You can't narrow things down to define access at the container level, or at the partition level, or at the individual item level. master keys can and should be secured in Key Vault, but if it gets leaked, again, it's full access to the account. So that's where resource tokens come in. And these have actually also been around for a while. They have issues as well, which is why we have an even newer and better model that follows. But they do have, there is something kind of unique about resource tokens and what they allow you to do. So first of all, they resolve the granularity problem. You can have granular control over different resources, either full or read-only access, but not just the entire account. It can be, it's actually defined at the database level, and within the database, it could be at the container level, or it could be at the partition level, or at the individual item level. Or for that matter, when I say item, I mean document, like JSON document, or even for that matter, stored procedures, triggers, or user-defined functions. And the way this works is pretty simple. You define, like I said, it's at the database level. So within the database, you define users and permissions. Right, so you create users, and then you create permissions for the users. And then at runtime, a resource token is generated from the desired permissions. And that resource token is a short-lived, by default, 1 hour. It can be configured to live up to 4 to 5 hours, I think. But you, instead of connecting with the master key, which is something that is highly sensitive and you would never want exposed, these resource tokens, they are short-lived and they provide limited access. And this is kind of the model that's often used for resource tokens. You'll have some client application, you'll have a middle tier, and you will authenticate your client application at the middle tier. How you authenticate is irrelevant. It could be through any identity provider. It could be Azure AD, it could be Okta, it could be Auth0. There are so many identity providers out there. However it is you go about establishing the identity of the user. Once you know who the user is, the middle tier, which has possession of the master key, uses the master key to connect the Cosmos DB and pass along the identity of the user and gets the permission or the permissions that you've defined for that user. And for each permission that you've defined for the user, you're going to get a resource token that grants permission just, according to that permission for by default for 1 hour. And then the middle tier will pass that resource token back onto the client app. And from that point forward, just to use the application, the resource token or resource tokens will be used in every request, and the request will be denied if you're trying to access a resource, a container, or a document that the resource token does not permit. But what's really interesting about this approach is that you can use this approach to implement a 2-tiered model, which can be appropriate. It's not appropriate in every scenario, but certainly in many mobile scenarios, you can have the client application on the mobile device communicate directly with Cosmos DB, connect directly to Cosmos DB. In other words, issue database calls directly to Cosmos DB with no middle tier. You still need the middle tier just for the purpose of brokering those resource tokens, like to authenticate, get the resource tokens for the permissions of that user, and then of course respond. In an hour you're going to get a 401 when the token expires, and respond to that 401 by re-authenticating and getting fresh resource tokens, right? But otherwise, the application in terms of data access can connect directly to Cosmos DB and get responses directly without any middle tier using the JavaScript SDK. It's just kind of an interesting point. Let's see a demo of resource tokens. Yeah, I see I'm a little bit behind, so let me try to pick up the pace just a bit. For resource tokens, under authentication. Go ahead and do that a run. And I've got 2 demos here. We're going to look at the partition key permissions demo. So this is a multi-tenant scenario, right? I'm going to create a database called multi-tenant, and I'm going to create a container partitioned on the tenant ID. And what I want to do is I want to set up permissions so that each tenant has access only to their data, right? Naturally. That's a very common thing, right? You don't only want the Acme user to have access to Acme documents, and you would only want the Wonka user to have access to Wonka documents. So I've created users Acme and Wonka. And in order to define permissions here, you set up permission properties. That's just the name of the permission property. It doesn't really matter. What I'm saying is that I'm granting all permission on a specific container, but not all the items. So first of all, I've locked it down to one container, but I'm saying not only just that specific container, but only documents with that partition key, Acme. Right, and then I'm going to create the permission based on those permission properties. I'm going to do the same thing for Wonka. The Wonka user, I'm going to create a permission on that Wonka user based on these permission properties that says that you have all access to the container, but only documents in the Wonka partition. And I'm going to define two documents in memory, but you can see that one is in the Acme tenant and one is in the Wonka tenant. So I think it's pretty obvious what I'm trying to do here. Clearly, the Acme document, I should be able to create that in the Acme partition, but not the Wonka document, right? So let's step into create document. And what I'm doing here is I rushed a little further up in terms of getting the resource token. So this token property off of the permission, this is the resource token. This is just a demo. So the moment I created the permission, I grabbed the token. But in reality, it would be like you would create the users, and then when these are authenticates, you would call this token property and pass it back to the client, who would then pass it in here to create the document, right? So now you'll notice that when I connect to Cosmos DB, I have my familiar endpoint, but I'm not using a master key. I'm using only the resource token, right? And so in this case, I'm trying to create an Acme document using the Acme permission, so that should succeed just fine, and that succeeds just fine. See, I successfully created the document. But now if I try to do the same thing with the Wonka document, that should fail because I'm using a resource token for the Acme user. I should not be able to create a document for another tenant. And so this time it fails, as you see. The reason is with a 403. Request is blocked. Check your authorization token, which is exactly what we wanted, of course. Now, I'm not going to single step through the next set of these next two lines because they're just demonstrating the exact opposite. This time, the first request should fail because I shouldn't be able to create an Acme document using the Wonka permission, but the second should succeed trying to create a Wonka document using the Wonka permission. And you'll see it's the exact same in reverse, right? So in the first case, the Acme document was created successfully, the Wonka document failed. In the second case, the Acme document failed, but the Wonka document succeeded, right? And that's how resource tokens work with Cosmos DB. Go ahead and delete that database. And I think I regained some time there, so I can pause to see if there's any questions at this point. If not, we can move on to the Azure Active Directory integration. I don't see any questions queued up, so I'm going to move on. So what's the problem with resource tokens? I mean, they seem to be definitely an improvement over master keys. Well, the issue with them is that, you have to manage these identities, right? You have to create the users in the database, right? And what if you have your identities elsewhere, like Azure Active Directory, right? That's much more ubiquitous, right? It's much more likely that you get a whole sets of users, sets of identities in Azure Active Directory, either at the user level or at the application level, right? Application identities and granular permissions depending on your Active Directory identity. And that's where role-based access control comes in Cosmos DB. This is much newer than resource tokens. I think it's only about a year old since they've rolled this out, not even. And what it lets you do is authenticate requests with either an Azure Active Directory identity or a managed identity. we're just going to go with the plain old Azure Active Directory. And it's a little bit involved. I mean, there's a lot of IDs that you need to grab. I'm going to walk you through. I'm going to show you what they are. Excuse me. But there's a lot of IDs that you need to grab and maintain. But you will be able to authorize your requests with these fine-grained permissions that are, essentially based on the Azure AD identity. No more master keys. No more resource tokens. Those things they just don't exist. And of course, all of the requests in the headers of those requests, you'll always be able to see who's issuing the request. So it makes auditing a lot easier as well. And it's based on a fairly simple permission model, conceptually simple, but there's a lot of ceremony and what the steps you need to go through. I'm going to show you all those steps, and then we'll demonstrate this as well. So there are these actions. These are the most basic things that you might want to do in the database. Operations like reading an item, writing an item, running a query, and there's a bunch more. Those are the most fundamental ones. And then you create these role definitions where you list the actions that are allowed by that role. So you have these role definitions, and then you assign those roles to AD identities, right? We'll see how this works. Here's a bit of a walkthrough for all the IDs that you need to grab. So here I am in Azure AD, and first of all, you need what here they're calling here the tenant ID, also known as the directory ID. This is the single directory for all the users, right? Right, so for all the users for your different applications. And inside of the Active Directory here on the left, when you click app registrations, you see I've created 2 app registrations, and each one has their own client ID. So in this scenario, I have one application that's responsible for ingesting data. That's its sole responsibility. I have another application is going to read and query the data that got ingested by the first application. So permissions wise, I want the application that ingests data to have only permission to do that, to write documents that are being ingested, but not to read them back and not to query against them, because that's not its responsibility. And likewise, I'll have another application that should not be able to actually make any changes, because it's just supposed to be able to do reads and queries. So I've got these 2 separate app registrations. Each has its own client ID. I need to grab the IDs of each one of those. Now, each one of those will have a secret, which is essentially like the password, but you'll need to know, and you'll need to grab that value right here out of the Azure portal, and one for the ingest application and one for the read-only application. Grab those secrets. So we have the 2 client IDs, we have the 2 client secrets, and then actually your running applications, those are the only IDs that you need. But to set up those role assignments that I was describing, and I'm going to show you more in a moment, to set up those role assignments and the roles, and then assigning Azure AD Azure AD identities to those assignments, you need 2 more IDs. Well, in this case, because there's 2 applications, you need 1 more ID, and since there's 2 applications, we need 2 more IDs. And for that, you have to go into the enterprise applications. This is not very intuitive, but it's just the way that it is. You have to go into enterprise applications and grab what they call here the object ID, but it's actually the principal ID. So for every app registration that you have that has its own client ID, there's a corresponding enterprise application whose object ID here is the principal ID that you need in order to set up those role assignments. So that's a bunch of IDs. You'll open up Notepad, you'll paste them all in there. So these are all, there's the directory ID for Active Directory and the client ID and client secret for each of the 2 applications. And that's all that's needed for the running applications. And then these principal IDs, if you will, that come from the enterprise applications object ID that we need in order to create the role assignments. How do we create the role assignments? Here I'm showing it in PowerShell. This can also be done with the Azure CLI, and as well, it can be done with bicep templates. So here I'm invoking the new Azure Cosmos DB SQL role definition commandlet. And I am giving it a role name as the ingest only role. And I'm listing the actions that are permitted. Now, it looks like I'm listing 2 actions, but really you always need that first one, read metadata. For the SDK, in order to be able to do anything, you'll need read metadata. It's just a permission that reads the most primitive sets of metadata about your account in order for the SDK to function. So you'll always have read metadata, and then beyond read metadata, you'll add what you need to add. And for the ingest only application, the only thing you want to be able to do is create items. So you have the items create action. Whoops. My screen went, sorry. Now, I also want to narrow this down to the IoT demo database. DBS is hard-coded, and this means databases. And so what follows is a database name. So that means that this role definition is limited to this one database in the account, right? So we're kind of narrowing the scope. That runs, and then you do the second part of that, which is to create a role assignment, where now I'm going to take that role that I just created. That's the name of the role that I just created that can only do item writes. And that role, if you remember, it was scoped to the IoT demo database. Well, calls, which means collections, which really means containers. Collections is the old name for containers. This means I'm narrowing it down even further to the IoT container within the IoT demo database. Right? So I'm giving very fine-grained permission here, right, for this role assignment. And there's that principal ID. Remember, it's the object ID of the enterprise application. You need that only when you're creating this role assignment, one point in time. So go ahead and plug that in there. And now I have assigned that role to that application that's associated with that principal ID, the ingest only application. And then you repeat that for the read-only application. Same process. 2 steps: create the role and then assign the role to identities in Azure AD, where those identities, you refer to them by their principal ID. So I'm going to call this role Cosmos read-only role. And this time, again, you'll always have read metadata, but this application has 3 permissions. It can read items like a point read. It can execute queries like run SQL queries. And hey, it's a read-only application. It should also be able to read from the change feed, right? But notice it has no write access, right? And again, I'm creating the role definition, narrowed down to the level of the database IoT demo. But then after I run that and I do the role assignment, I narrow the scope down even further again to the IoT container. So we're giving fine read-only access just to that container to this application. That's the principal ID, which is the object ID of the enterprise application of the app registration for the read-only application. And that runs. And now that I've done all that setup, let's actually see it. So let me flip back on over to Visual Studio, where you can see I've got a project here for authentication. If we look, this is just a demo, right? So I've got all the IDs in one app settings. In the real world, that would never be the case, right? The ingest only application, but both applications need the directory ID, the Azure AD directory ID, the tenant ID, where the users are defined. And then the ingest only application will then additionally need these 2 values, which is the client ID and the client secret, while the read-only application would only have these values. Like one application would not know about the values of the other, but this is just a demo, so I've lumped them all together. And I'm going to go ahead and now give this a run. We'll single step through it, and you'll see kind of what I'm talking about. When I type IO, then I am emulating the ingest-only application. And when I type RO, then I'm emulating the read-only application. So let's do the ingest-only application first. With the ingest application, right, here's my app settings JSON. I need the endpoint. But now there's no master key, there's no resource token. Instead of those things, we have the directory ID, the Azure AD directory ID, and the client ID and client secret for the ingest-only application. And I take those values and I create a client secret credential around those objects. And then I use that credential instead of the master key or a resource token to new up my Cosmos client. And now I have access to the IoT container inside of the IoT demo database, which is exactly how our permissions were set up. Because I'm the ingest only application, I ought to be able to write a new event to my container. So I've got a new event for a new device. This is sensor data being written to a partition, and it looks like it has succeeded. Now, what about reading back the item that I just wrote? Like, I know the partition key and I know the ID, so I can do a point read, right? Read the item async. Even though when I say I mean the ingest only application was able to write that document, I can't read it back. And here I'm catching a Cosmos exception, and the status code is forbidden. It's that same 403 that we saw on the firewall demo, and the permission was denied for the point read. Certainly can't do a query. That will fail as well. See, that fails as well. But now on the other hand, so you can see I was able to successfully create a new document, but I couldn't do a point read and I couldn't do a query. But on the other hand, if I connect as the read-only application, right now I'm emulating the read-only application that again uses the same directory ID, the tenant ID, right? But this time it's using the client ID and the client secret for the read-only application. And just like we saw before, we create a client secret credential around those values. We use the credential object in our Cosmos client constructor. Instead of a master key or resource token, we have access to the container. I ought not to be able to write a new event because this is the read-only application. And so the create item async now you see fails with a 403. Permission denied to create a document. But what about reading an item? With a point read, read item async succeeded. What about a query? Like read the entire container, or let's say at least read the first page of the results from the entire container. That succeeded as well. So there's Azure Active Directory. Very sexy, very cool, and great way to implement authentication with Cosmos DB. We have let's see, a question here. We have a requirement for third-party integration. We have a requirement for a third-party integration company to dynamically create containers and read-write data into our Cosmos DB. Their software is hosted in AWS. In this scenario, would we have to use master keys, or could we use something like OAuth? They do need to create containers though, so not just reads and writes. I don't know about OAuth, unless you can get OAuth to integrate with Active Directory, but if the software is hosted in AWS, it doesn't sound like that's likely. I would have to think that the answer is no, you need to continue using master keys, but I would certainly research it further. But off the cuff, it sounds to me like you would be using master keys in that scenario. All right. We are getting near to the end of our session, kind of taking us to our third topic, which is encryption. So you've gotten past the firewall or the private endpoint. You've gotten past authentication. Can you still access all the data, or might we have some data that's encrypted? Well, on the server side, and this has been since the beginning of time with Cosmos DB, you have built into the service encryption, right? Microsoft manages encryption keys that it uses to always encrypt your data at rest. And in flight, there's always network layer security, whether it's SSL or TLS, whatever it is. So on the server side, in flight and at rest, your data is always encrypted. But you'll never be able to see the encrypted version of that data from the client. But it is always encrypted on the server side. In flight with network layer security, you can't disable this, and at rest as well, using Microsoft managed keys, and you can't disable this. So you have your data, and it always gets encrypted by a Microsoft managed key. There's an option for if you don't trust Microsoft, if you will, because this is really not encouraged. You can use your own encryption keys. It will give you an extra layer of protection, but it also gives you an extra layer of responsibility. Because if you lose those keys, Microsoft will not be able to help you. You'll have to maintain those keys. You'll have to rotate those keys. It'll be your responsibility, and it's not encouraged unless you absolutely have to do it, like your industry demands it for security compliance reasons. But like I said, it's an extra layer of encryption. So you're still going to get the Microsoft managed key based layer of encryption around your data. And then layered on top of that, Microsoft will encrypt that using a key that you possess in Key Vault, and you better not lose it, or you'll not be able to ever access your data again. So that's why it's generally discouraged. Don't use it unless you have to, but if you have to, the capability is there for you to choose data encryption. The default is service managed key. Like I said, Microsoft manages the key, but if you choose customer managed key, then you enter a URI, a path, if you will, to your own key that you got in Key Vault, and just don't lose it, is all I can say, because you'll be out of luck. What's much more interesting and much newer is something known as client-side encryption with always encrypted. Okay, and so a quick review of that server-side encryption. You have your application, it generates data. That data is not encrypted on the client side. Like I said, as soon as it makes it over to the server, like whether it's SSL or any other network layer of encryption, it is already encrypted. And then Microsoft will immediately add another layer of encryption so that it gets persisted encrypted. And even as that encrypted data passes into Cosmos DB, there's another network layer of security. And then it comes back out the same way. Unwrapping the SSL layer on the client side, you get the decrypted data. So that's why the client never sees the encrypted state of the data. With client-side encryption, we are going to leverage the power of the SDK. So this, by the way, this feature I don't think it's been released yet. I think it's still in public preview. I'm not sure. This is very new. And what it lets you do is, using a customer managed key, that's a key of your own, encrypt certain properties on the client side, right? And only designated applications that are authorized using Active Directory are able to perform cryptography operations, encryption and decryption. Where you might say, there's a credit card number property in my JSON document, and there's a password property in my JSON document. And those properties should always be encrypted, even on the client, except on the client, I mean. Like, only the client can encrypt and decrypt these things. So once it leaves the client, right, it travels across the network. Even if somebody has managed to strip away the SSL layer of security, they will not be able to see the credit card number and the password, right? Unlike the other properties, which would then be exposed if you cracked the SSL. And then you get the normal layer of server-side encryption on top of that. But even if Microsoft strips that away, they don't have access to the credit card number or the password, and then it makes its way over to the server and back and so on. And then when it comes back all the way to the client, it's still the credit card number and the passwords are still encrypted, even after the rest of the document has been decrypted, because the customer managed key is used then by the SDK to then decrypt the credit card number and the password, assuming those keys are available. So here's an example. Here I've got some sensitive data like the salary and the social security number. I want to protect those. Like, ordinary clients should never be able to see those values. So what I'm going to do is I'm going to create a key inside of Azure Key Vault for the salary, and I'm going to create another key inside of another Key Vault for the social. Now, in fact, you can have one Key Vault with multiple keys, but you'll see that the way this works is you define an access policy, and the access policy is defined at the Key Vault level, not at the key level. And since we need different access policies for two different applications that are going to have different levels of access, we'll need two separate key vaults. Now, an ordinary user application would have access to neither key vault, and therefore would not be able to access the salary or social property. But let's say I've got two other applications. Let's say the staff application. Let's say the staff application should be able to access the salary or the staff application just simply can't function if it can't access the salary. But the staff application should not have access to the social security number. Well, we will add the staff application, or more accurately, the app registration that we define in Active Directory for the staff application. We'll add that to the access policy of the key vault holding the salary key, the salary customer managed key. But we will not add the staff application to the access policy of the other key vault for the social. Now we have another application, the service application. This is the all-powerful, like it needs to be able to do everything. It needs access to the salary and the social. So we will add the app registration in the Active Directory for the service application to both key vaults. And so we should have access to both properties. And let's see how that works in our final demo of the session. Always encrypted in client applications. Okay, all right, so that, like I said, that will be our last demo. So let me flip on back over to the Azure portal, where you can see I've got these two key vaults here. This is just like for what we just saw on the slide. You know, it's the same scenario. I have a salary key vault and a social key vault. If I go into the salary key vault and I look at the access policy there, I see only, I'm sorry, yes. This is right. I see both applications, both the service application and the staff application have access to the keys in this key vault, which is going to be the salary key. Here it is. Here's this. This is for the salary key, the salary SIM key, and it has its own URL. If I go to the other key vault for the social security number, which is a bit more sensitive, this is the key for the social security number. SSN CMK. If I look at the access policies here, I only see the service application. I don't see the staff application. The staff application is not in the access policy. The staff application will not have access to the CMK for the social. So the staff application will have access to the salary property, but not the social property. So let's head back on over to Visual Studio. For our final demo here under encryption. And let's first run as the service application, right? So now the service application, so let's look at app settings JSON. And let me point out a few things here. Your applications will normally only need, okay. So I'm first of all connecting with a master key. I don't want, this can get a little confusing if you're using Azure Active Directory for two things. One, for authentication, which we just covered, and two, for always encrypted, client-side encryption, which I'm covering now. And you could do that, and then you would have two sets of client IDs and client secrets, and it would get a little confusing. So the only Active Directory related code in this demo has to do with encryption. For authentication, we're going back to using our good old friendly master key. Okay, so in order to handle the encryption and decryption client side, I just need these three values. Now, why do I also have these other values? These are the customer managed key. These are the key IDs for the salary and the social, because this application is also actually going to create the container, which is like a one-time thing that you do. So, you know, you might have a dedicated application whose purpose in life is to create the container, because you have to create the container with the SDK. You can't create the container with the Azure portal, with the Data Explorer, if you want to use this feature, because it is an SDK feature. And so you have to, when you create the container, you're not just creating an ordinary container, you're also defining an encryption policy for the container. And when you do it at that one point in time, you need the key IDs in order to create that encryption policy. So because this application is not only going to use the data in the container, but is actually also going to create the container in the first place with an encryption policy, that's why I also need these two values. Otherwise, they wouldn't be in an ordinary application. So with that established, let's run the service application. And right, so an endpoint and a master key. That's how we're going to authenticate. But for encryption, I need the Azure Active Directory ID and the client ID and the client secret for the HR service application. Okay. And I also have to create what's called an Azure Key Vault key store provider around those credentials. So these are the same client secret credentials we use for authentication, but now that we're using it for encryption, we have to wrap it. We have to wrap an Azure Key Vault key store provider around those credentials. And we create a new Cosmos client object, referencing that key store provider. So it's tied to the service application, right? And now I'm going to create the database, which is very ordinary, right? I could even do that in the portal. That I could have done in the portal, right? I just created a database. But now I have to create the encryption policy for this container, right? So follow along. It gets a little funky now because I just talked about the customer managed key. In fact, what encrypts your data is not that CMK. What encrypts your data is a DEK, a data encryption key. Where is it? Data encryption key. Okay. And this is going to create the DEK. And so the data encryption key is a data encrypting key. And the CMK, the customer managed key, is a key encrypting key. The CMK encrypts the DEK encrypts the data. So I get the key ID for the CMK that we just saw in app settings. And I have to create a new encryption key wrap metadata around that. And I'm creating a DEK which uses SHA-256 encryption. And now I have a DEK for the salary property. I do have to do the same thing for the social. There's a key in the configuration. I have to wrap encryption key metadata around that. And I'm creating the social security number DEK, right? And now I have two DEKs. I created a database and I created a salary database encryption key and a social database encryption keys, those two DEKs, which in turn are both encrypted by the one CMK. And now I have to define the paths. I'm saying the salary property in my JSON document should be encrypted by the salary DEK. And again, it's always SHA-256. Notice I'm using randomized encryption, which is preferred, but I won't be able to query on the salary. This path here for the social, I'm going to do the same thing. I'm using the social DEK in this case, but I'm going to say it's deterministic. It's going to allow me to query on it. Now I can create the container with those two paths in my client side encryption policy, throughput of 400. And now I'm going to add two employees. There's what should be encrypted, right? On the client side, it's going to get encrypted automatically by the SDK. That's salary and social. And again, this is salary and social. So I created those documents. If you flip on over to the Azure portal and you look at that data, and I see I have 1 minute to go. If you look at the employee data, oh, geez, come on. Look at the salary. Look at the social. This should drive home the point how, like on the server side, it's this can only be decrypted on the client. And as we wrap this up, you can see that I can do a point read. I can read the document back. I can see the social and the salary as the service application. I can even run a query. I ran a SQL query and I can see the social and the service app. I was even able to run a query against an encrypted value. But the staff application and I see it's exactly 7:45, so I might get cut off here, but I really wanted to just show you how the staff application, I'm just going to run it without the debugger because we're out of time. You'll see how the staff application fails to read the social, come on. Sorry, one more time. Tries to retrieve the documents with all properties, and it fails to do that because it can't access a salary. But if it, instead of saying select star, if it doesn't include the social, then it's able to retrieve it.